Hey guys, now that we know how to graph inequalities, we're going to look at what a solution to an inequality is. So first, just some definitions. Any number that makes the inequality true is a solution or answer for the inequality. So think about things that if you plugged it into the inequality, it would make a true statement. Like if you said 6 is greater than 3 or 10 is greater than 2. Okay, those things are true solutions. Okay, they have the inequality symbol and their statement is true. An inequality may have many solutions. Okay, so if we say something like x is less than 1, 0, -1, -2, -3, all of those would be solutions. So with equations, we had things like x was equal to 7. There was only one solution to that. With inequalities, we're going to have lots of solutions. So we need to know whether numbers are solutions to our inequalities. One part that gets a little bit tricky is when we have greater than or less than symbols without the equal to line, and then when we have the equal to line. So think about the graph. When we have a greater than symbol, we just have the open circle, and the open circle means the number is not included in the solution. So like here, if we tried to plug in 1, 1 is not greater than 1, right? That's not true. So this open circle, it's not included. Okay, and we use that with greater than or less than symbols without the lines. But if we think about the ones with the equal sign underneath, the closed circle means the number is included. Okay, so if we think about plugging in -2 to this one, if we plugged in -2, -2 is less than or equal to -2. Okay, it's equal. That's why we have the line underneath that shows it's equal. The closed circle says that that is part of our solutions. Okay, so we're going to use that with the less than or equal to or the greater than or equal to. Okay, let's kind of get into some examples so you can see what we mean. On our graph here, we have x is less than or equal to 11. So then it says, is 11 a solution? So one way we can figure it out is to plug it into our inequality. So instead of x, we would plug in the number that we're testing, which is 11. So 11 is less than or equal to 11. Well, this is going to be yes, it is a solution, because 11 is equal to 11, so it is a solution. Let's try 12. Is 12 a solution? So this time we'd plug in 12. 12 is less than or equal to 11. Well, no, that's not true. 12 is greater, right? This is not a true statement, so it is not a solution. You can either plug it in like this or look at your graph. If we look at our graph, anything that's in blue is part of our solutions. So like 11 is included, 10, 9, 8, 7, 6, all the way down, right? But if we look at where 12 is over here. It's outside of this blue area. So it's also not a solution because it's not part of the graph. So if we know how to graph, we can use our graph to help us decide, or we can plug it in like I showed you. Okay. Let's test another one. This time we have x is greater than 11. It has an open circle because it's not equal to it. So let's test 11. 11 is greater than 11. Well, that's going to be a no. Okay, right? 11's not greater than 11. It's equal to, but we don't have that line underneath, so we can't say yes to this one. So we're going to say no. Let's try 15. 15 is greater than 11. Well, yes. When we plug it into our inequality, 15 is greater than 11. Okay, also 15 would be over here on our number line. It's bigger than our 14, but it's included in all this blue area. It's included in our solutions. So 15 is a solution. Okay, next one. X is greater than 5. They didn't give us the graph yet, so we're just going to test 5. So 5 is greater than 5. Well, that's going to be no. Right? It's equal to, but it's not greater. So this is a no. Is -1 a solution? -1 is greater than 5. Well, that's also a no, right? Negative numbers are not bigger than positive numbers. So this is going to be a no again. Okay, now they want us to graph it. So since it's not equal to, we're going to put an open circle at 5. Okay, and x is greater, so we're going to shade towards the right. It has all of our numbers bigger than 5, like 6, 7, 8, 9, 10, all the way up. Okay, now they want us to shade all the solutions. Well, for the first one, 5, we already decided that 5 was not a solution, right? Because it's not greater than 5. So we cannot shade this one. Let's put an X on that. What about 10? Is 10 in our solution set? Well, 10 is greater than 5, and it would be into our graphing part here, so we can shade that one. Okay, so we're going to shade our 10. What about 0? Is 0 greater than 5? No, right? That one's out too. What about 2? Is 2 greater than 5? No, so that one's out. If we look at our graph, 0 and 2 are down here. They're also not in the graphed area of our number line. So that's another way we can tell that they don't fit. -5. -5 is all the way down here. It's not in the graph, so that's also out. -12. It's not on our number line, but it would be somewhere down here, right, all the way to the left. So that one's going to be out too. 1/2 would be here, also not in our graphed area, so that one is out. But 12 is greater than 5, right? If we plugged it in, 12 is greater than 5. Also on our number line, it would be somewhere over here all the way to the right, so it's going to be in our solution. Remember, this arrow keeps going on forever, so it's going to eventually pass our 12. So here we're going to shade in 12. So we only had 2 solutions, 10 and 12. Okay, let's try our last one. First, we're going to test some solutions. Is -5 a solution? Well, let's plug it in. We have x is less than or equal to -3. So -5 is less than or equal to -3. This is going to be a yes. The negatives are a little bit tricky, but remember, the bigger the number here, the smaller it is on our number line. If we look at our number line, -5 is further away from 0. So -5 is less than -3 because it's further from 0, so it is smaller. Okay, is -2 a solution? -2 less than or equal to -3. Well, that's going to be no, right? -2 is closer to 0, so it is bigger. It is not less than or equal to -2. Okay, if we were unsure, the best way to tell is by graphing it. So this time we have the line underneath, so we can fill in the circle at -3, right? And it's less than or equal to, so it's going to go down towards our negatives, and there's our line. And just to double check, -5 is in that graphing solution, so we're good that we said yes. -2 was not, it's outside of it, so it's good that we said no. Okay, let's look at our solutions. -1 is not inside of our graph, it's over here, so that one is out. Same thing with +1, it is outside of our graph, so that one is out. 0 is also outside of our graph, so that one is out. -4 is inside of our graphed area, and it is less than or equal to -3, so we're going to shade that one in. Same thing with -5, we already said yes to that one. It is inside our graphing area, and it is less than -3, so we are going to shade that one in. 5 is way outside of our area. It's positive, right? So we're going to take that one out. Same thing with +3. It's definitely not smaller than a negative. -3 is equal to -3, so since we have this line here and it's a closed dot, we're actually going to shade this one too, because it's not less than, but it is equal to. So we've got 3 that we've shaded in here. Okay guys, on the back of this, there's some for you to try. Please get it checked before moving on. Thanks.